Okay, welcome to week 14, office hours. In this video, I'm going to take the practice logic quiz number 3. Let's see, let's go to practice quizzes. Logic quiz number 3. Okay, so this material covers Unit 2, Mods 3 to 5. Remember, that's translations, truth tables, and proofs. It's primarily about proofs, but there will be a little bit of this to make some connections. 12 questions, each worth 5 points, total of 60 points. Technically, there's 15 questions. Question 12 has 3 parts, and the easiest way to write it was to make it 3 questions that add up to 5 points. So, but at the same time, it was never mind. This is a practice quiz, but it will look, the format will be exactly like the actual quiz, which you should be familiar with by now. There are short answer questions. I don't grade those on practice quizzes, but it's still worth doing them as practice, and you will see the sample answers. And as usual, you'll have 2 attempts at the actual quiz. There will be different quizzes. Okay, always read the instructions for everything you do for an assignment in any course. It'll serve you well. Critical thinking, tip number 1, read instructions. Even if it's annoying and slow. Oh, hey, more instructions, read them. So for many of the questions on this quiz, you'll be completing auto-graded proofs where you're asked to supply derived statements, basically complete the proof, and or their justifications, which requires both line numbers and a rule. So be sure to enter the right things in the right boxes. Don't include any spaces in any of your answers. I know this is really annoying, but it would be better for both of us if you remembered to do this, so that way you don't have to email me to ask me to correct stuff and I don't have to correct a bunch of them. Put commas between your line numbers. For CP and IP, it's not a comma but a dash because you're citing a bunch of lines, not just 2 lines usually. So you'll put this for those proofs. Just put line numbers in numerical order. It obviously doesn't matter what you're just citing, the 2 lines in the, but for auto grading reasons, put them in numerical order. Don't spell out the rules. Don't use unnecessary parentheses, but do use necessary ones. Copy and paste the appropriate symbols, or you can use these. Capitalization doesn't matter, but number 1, don't include spaces in any of your answers. If you do get an auto grading error and you lose some points, you can send me a remind message or an email, and I'll correct it. Ideally, tell me where you lost the points, but just knowing which assignment it is. Okay, so first question is, in which of the following is line 3, so I see that each one of them is a 3-line proof, correctly derived as specified by the included justification? That's line numbers and rule. There are 3 correct answers. Okay, so A, if A then B, not B, A therefore not B by 1, 2 modus ponens. Modus ponens applies to a conditional statement, check, and we have the antecedent and we conclude the consequent. That is definitely modus ponens. Okay, this one says it's also 1, 2 modus ponens. Conditional statement, check. Do we have the antecedent? No, we have the consequent, and we've concluded the antecedent. That's a fallacy. You could do a truth table to show that this argument would be invalid. Okay, 1, 2 modus tollens. Modus tollens applies to conditionals, check. It says we would need the negation of the consequent on a line. We don't have that. We have the negation of the antecedent, and we've drawn that as a conclusion. So this is not modus tollens. That's a fallacy. You could do a truth table to show this is invalid. Okay, another one says it's modus tollens. The conditional, we have the negation of the consequent. Looks good so far. Did we conclude the negation of the antecedent? Yes, we did. This is a case of modus tollens. Okay, this one says we used 1, 2 DS. DS applies to disjunctions. Is this a disjunction? No, it's not. Not even in the running. Okay, 1, 2 DS. DS applies to disjunctions. We've got one. We have the negation of one disjunct. Did we conclude the other disjunct? No, we concluded the negation of that disjunct. That is not DS. You could do a truth table to show that's invalid. 1, 2 DS. The disjunction. We have the negation of a disjunct. We concluded the other disjunct. So this is DS, and correct application is DS. So we've got 3 so far, so this one should not be a good one. So modus ponens applies to a conditional. However, although there's a conditional here, and it looks like we've got the antecedent and included the consequent, we can't do this. You have to have a conditional on its own line. This is a disjunction that has a conditional as one of its disjuncts. Modus ponens does not apply here. Okay, use the given justifications, line numbers, and rules to complete the proof. So we've got a proof. What can we derive from one simp? Well, there's 2 answers here. We could either get not L or we could get N. So we have to ask ourselves, which one of those things are we going to need? We don't. So let's pause on that one and look at the next. 2 for DS. So I know that I'm going to look at 2. That's a disjunction. And 4, and I'm going to use DS. So 4 needs to be the negation of one of the disjuncts. So which one of my things I could put on line 4 is the negation of one of these disjuncts? N is. So now we know we're going to get N, and then 2, 4 disjunction. We've got the negation of not N here. So we can conclude the other disjunct by disjunctive syllogism. Okay, 3, 5, modus ponens. 3 is a conditional. 5 is the antecedent, so we can get the consequent on its own line, G or L. No spaces. If you're copying and pasting, once you've copied and pasted, immediately remove spaces. All right, 1 simp. Since we already, technically we could do N or not L, we could do N again here. There's nothing that says you can't derive the same thing twice. The only thing constraints on you are you have to apply rules correctly, and the last line has to be the conclusion you're trying to get. So we could put N here, but probably that's inefficient. We don't want it. So let's simplify off that other conjunct. And remember, simplification only applies to conjunctions. You cannot just take apart any old thing. If you know that both of these things are true, you know that one part is true. This is a disjunction. It means one or the other is true. So you can't conclude that you know one part is true. Anyway, moving on. 6, 7. We've got a disjunction. We have the negation of one disjunct, so we're going to get the other one. Also, we know we want G at the end. The last line should be G. Okay, so we completed that one. Got another one just like it. Okay, so 2, 3, modus ponens. We've got a conditional antecedent. We will put the consequent on that line, and we immediately, when we copy and paste, remove spaces. Okay, 4 simp. 4 is a conjunction. We need to take one part, but there's 2 options, and I'm not sure which one we need yet. So what do I do? 2, 5 conjunction. B. Well, what thing? So I know that whatever I put here is going to be, it says 2, 5, it's going to be B in something or something in B, but like how do I know which one I want? Okay, maybe I don't yet. 1, 6, modus tollens. Okay, now that depends on that, which I already don't know. I know my last thing is going to be this. So I'm going to fill this in. All right, I'm going to get this by 5 and 7 conjunction. So one of these is L and one of these is H. Well, I know that the only thing that 5 could be is L because I'm simplifying for simp, either L or, so that's one way I could figure it out. Another way I could figure it out is to reason through the proof. I need to get L and H, each on a line. I see how I can get L. I can simplify L out of this conjunction, get that out. So now I need to get H. How can I get H? There is, the letter H shows up, not H in particular, shows up in this conditional. And what I want, just plain old H, is the negation of an antecedent. So I'm thinking if I used modus tollens to get H, I would need the negation of the consequent, which is L and B. So how can I get L and B in order to do modus tollens? Well, I've got L and B is on a line here, so I'm going to get L and B because I know I want to use modus tollens. And indeed, 2-5 conjunction is B, L. And specific, I don't want B and L, I want L and B, because I want it to be exactly the same as I want it to be the negation of the consequent here. Remove the spaces. Okay, now I can use modus tollens. 1, 6 gets me H, and then I can put those together to get the conclusion. Proof complete. Okay, next proof. This one, I see ACP immediately, and that is a conditional statement. So I know that this is a conditional proof. Where to start? Okay, so how could I get, I'm just gonna, before I start filling, I'm gonna look at the proof I've got. So I know where I'm going. I ultimately wanna have a conjunction, and I'm usually, if what you want is a conjunction, the rule that lets you create a conjunction is the conjunction rule. My guess is that I'm going to get this not by like modus ponens, or I'm going to create it with a conjunction. That means I want to get each conjunct on its own line. Hey, that's what I've got here and here. Each of these conjuncts is on its own line. So I need to get this, and then it looks like I create a conditional proof to get this other one, which makes sense because one of the conjuncts I want, in fact, both of them, is a conditional proof. And one thing you should think when you want a conditional is conditional proof is an option. I can do a conditional proof to get this. So let's see. Let's get started. So we kind of have a sense of like, I'm trying to get these two conditionals. You could potentially think I should do a conditional proof to get any conditional, but it looks like we could get this first one without doing a conditional proof because it's not set up to do one. How do we get it? Well, this one is the consequent of a conditional itself. We've got the antecedent of that conditional on its own line. So we can use modus ponens on lines 1 and 2 to get that one. Now our goal is to get this one, and it's clear that we used CP to get it, and it's lines 5 through 7. So now we just have to fill in. So the conditional proof is a subproof. Assume X were true. Assume for the sake of this proof that X were true. If X is true, then, well, since we already have this on a line, we know that G is true by modus ponens. 4, 5, modus ponens. And if we know that G is true, then because up here, line 3, we know that if G, then not W is true, then we know that not W must be true by 3, 6, modus ponens. So what we've shown is that if X is true, not W is true. So we're just stating this thing that we've shown. If X is true, then not, I didn't say X was true. I just said if X is true, not W is true. I showed that W follows from that X. 5 through 7, CP. Now that I know that both of these conditionals are true, I know that the conjunction of the two of them are true. So that is 4 and 8 conjunction. Here we're doing an indirect proof. So with a conditional proof, we show that this conditional has to be true, because if we assume the antecedent were true, then the consequent would have to be true. With an indirect proof, you're assuming the negation of something. You show that that leads to an explicit contradiction. And if this leads to a contradiction, then this must be false. So we'll assume the negation of it. Let's look at the proof as a whole. We could just start seeing what we can do and filling in justifications, but let's try to reason through the proof as a whole. So we ultimately want X. You see that's the last line here. I'm first going to look for X over in the premises here, and I see that it is part of a disjunction. And so one thing I immediately think is, if I had not B, I could use DS to get X. And maybe that's one reason why I decided, well, how do I get not B? Like I can't, this is I could take this apart, but if I'm, doing this with pen and paper, if I'm doing this on pen and paper, I might eventually get myself to realize that I don't know how to get not B. I need not B. And so you decide, well, since I want not B, let's assume B and see what happens. And if you assume B and it leads to a contradiction, that gets you not B, which you could use not X. Alternatively, you could just try to get not X, or to get X by doing an indirect proof. For fun, maybe do it this way and see if you can figure out how to do an indirect proof to get X. So if what you want is X, assume not X, and see if you can show that that leads to a contradiction. And that should happen because, think about it, if you assume for the sake of argument that not X is true, that allows you to get B. And if B is true, well, here we've already, as we'll prove in a moment, if B is true, a contradiction follows. So if not X is true, B is true, and if B is true, this contradiction is true. So we could construct an indirect proof directly for the conclusion. Why didn't I do it this way? Because I wanted to show you that, or have an example where we use indirect proof to get something other than the conclusion. Likewise up here, we used conditional proof to get something other than the conclusion. You can use conditional proof and indirect proof to get your conclusion. You can use conditional proof if your conclusion is a conditional, and you can use indirect proof to get just about anything, but it's not always as strategically useful. But you don't have to use these to get the conclusion. These are rules you can use at any time. Technically, we aren't doing that in this class, but technically you could open up a subproof within a subproof. All you have to do is apply the rules correctly. There's actually more things you can do with them than we're doing. Okay, so our goal is to use DS to get X. We need to show that B leads to a contradiction because we want not B. Why did I start doing some things up here? Well, whenever I see a conjunction, I just immediately take it apart because why not? We might need it. So one simp, one simp. Okay, now that we've assumed B, how did we get this? Well, let's go up here and look. Here's part of it, right? And I got the negation of this. Since I put on a new line, the negation of an antecedent, I'm thinking modus tollens, and indeed, line 6 is the negation of the consequent. So 3, 6 modus tollens. Okay, next I've got C. How did I get C? Well, in my previous line, I have a disjunction where C is one disjunct. In order to get C from this, if that's how I got it, then I must have the negation of the other disjunct somewhere. Oh, hey, I do. It's up here. So 4, 7, DS. Okay, now I've got a conjunction here. I probably used conjunction to get it. C and not C. I've got C here. I've got not C here. So 5, 8, conjunction. Now that I've derived the contradiction, I end my subproof, and I conclude the negation of the thing I assumed to start off with. So I'm going to justify this 6 through 9, indirect proof. Now that I've got not B, I can use DS to get X. So lines 2, 10, DS. All right, complete the following proof. So I recommend doing proofs with pen and paper, especially when you're asked to complete the whole proof. Sketch it with pen and paper first and then fill it in, unless you're finding this super easy. I mean, you can do what you find easy, but sketching them, especially if you've been practicing with pen and paper, you want to, I know that time might feel like an issue, but the more you practice, the less time will be an issue. And sketching stuff out with paper shouldn't take that long because there's not that much to write down. And making mistakes takes longer than sketching stuff out on a piece of paper, usually. Okay, so a good thing to do is just to take part conjunctions wherever you see them, and that's what this proof is suggesting that you do, in part for auto-grading reasons. 1 simp. Okay, so we've taken apart that conjunction. Now what do we do? Ultimately, we know what we want, so we could just fill that in right away. Here, remove the spaces. And this is a conjunction, and I don't see X and Y up here anyway, so it seems like the only way I'm going to get that is by making it with the conjunction rule. It means I need X and Y on its own line. I have X on line 3, so probably this is going to be Y, and I'll cite 3, 5 to get that conjunction. So the question is, how do I get Y? Well, I see that Y is up here. It's the conclusion or the consequence of a conditional. And the rule that allows me to get the consequent of a conditional is modus ponens. If I have the antecedent, do I have that? Oh, here it is. So 2, 4, modus ponens. Again, I recommend pause the video, write this down on pen and paper. Maybe you're doing the practice quiz as you do it, or maybe you're going to take the whole practice quiz on your own after watching the video. But in any case, write down the proof, do it by hand. Recommendation. All right, where to get started? So I know that I want not A ultimately. I'm going to start by looking at where A is in the proof. I see it's here. So I'm thinking I'm going to want to get this on its own line at some point. This is the consequence of a conditional. So I'm thinking I'll need to use modus ponens to get this on its own line at some point so I can get the A out of it. That means I want not R. I see that not R is right here. Oh, if I use disjunctive syllogism, I can get not R on a line, and then modus ponens will get me this, and I'm at least getting closer to getting A on its own line. Okay, so W or not R. Not W, therefore not R. 1, 3, disjunctive syllogism. Now that I know that if not R is true, then this is true. Not R is true. Therefore, this. Remove the spaces. And that is lines 2 and 4, modus ponens. Okay, ultimately I know that I want not A on the last line. How did I get it? Well, I've got this conditional, I've got the negation of the consequent, and I've concluded the negation of the antecedent. So 4, 5, modus tollens. Okay, this one looks longer. So ultimately I'm trying to get to D. D is going to be the last line. I see that D is only in one spot here, and it's the consequent of a conditional. And that immediately makes me think modus ponens. So what I want to have is not A and not C, so I can use modus ponens to get D. So my new task is get not A and not C on its own line. How do I do that? Well, I've got not C already, so if I could get not A on its own line, I could use conjunction to get these two. If I was writing this down by hand, I'd start maybe sketching. Like I'm going to put, I don't know if it'll go here or not, but I would sketch something like, put this here, and I'd fill in like I'm thinking conjunction. I don't know how I'm going to get this yet, but I think I can get it, and I'm thinking modus ponens for this. But so since I've already got not C, now I'm thinking, oh, I want not A. So not A, how am I going to get that? And now I look at, well, what do I got? How do I get not A? Well, not A is something I could get if I used modus tollens on this conditional, because modus tollens allows us to get the negation of an antecedent. But that means I need the negation of the consequent. So that means I need not B. So I'd fill in like not B is a thing that I need. I don't know what order or anything is. I'm just, if I was sketching this on paper, I'd be writing need not B. So how can I get not B? Don't know, don't know. Let me look. Well, not B is right here. It's part of a disjunction. And I have the negation of one disjunct. So I can get not B by using disjunctive syllogism on lines 2 and 3. Okay, so this is starting out. So now that I've got not B, that's the negation of the consequent of this conditional. I can infer not A by 1, 5 modus tollens. Now that I've got not A, I can create the conjunction not A and not C, because I've got not C on line 3 here. So I have to remove these spaces. Make the conjunction lines 3 and 6 conjunction. Check. And now I've got the antecedent of this conditional. So I can use modus ponens, lines 4, 7, to get my conclusion. End of proof. Okay, so for questions 9 through 11, complete the proof by hand. So these are going to be short answer questions. It looks like there's instructions, formatting instructions. Let's read those. Since you can't draw the box to indicate the bounds of a conditional or indirect proof, just make something up that makes it clear where your subproof is. Here's one kind of thing you could do. Use these little dots. You could change the color of the subproof too. You could put lines before and after the subproof. Just make it clear that part of this is the subproof. Okay, so let's do our first one. Complete the following proof. Hint, use CP. Okay, so we've got a disjunction. The conclusion is a conditional. So I'm thinking I'm going to use CP to get this conditional. I use CP when what I want is a conditional. So I'm thinking like I'm going to assume P and ultimately get Q and it'll look like that. At least I'm just sort of sketching stuff in. Okay, so one thing I might do is before I even open up the conditional proof, is there anything I can do? Can I use DS? No. Can I use MP? No. Can I use MT? No. Simplification? No. I could use conjunction, but the only thing I could get is the conjunction of lines 1 and 2, and I don't want that. So it looks like line 3, and you can either copy the, I don't care if you don't copy the premises, you can do it or not. I'm going to do line 3 as my open up my subproof for, I don't know if formatting will stay, I'm just going to use the dashes just to make sure the formatting works out. Okay, so assume P, and my justification for this is ACP. Assume for conditional proof. What follows if P is true? Well, now I have a conditional, and P is the antecedent of that conditional, so not K follows from 2, 3, modus ponens. What next? Right now, I could conclude if P then not K, but I don't want that conditional. So a common mistake that people use is using conditional proof to get a conditional you already have. You don't want a conditional you already have. You want a conditional you don't have. In particular, we want the conditional if P then Q. So let's continue. If we know that K is true, or not K is true, what else must be? Well, we've got this disjunction. We have the negation of one disjunct, so we can conclude the other disjunct from 1, 4, DS. Now we've got the antecedent of the conditional we want as our assumption, and we got the consequent we want as the last line of the proof. So let's end this proof, and on the next line, we will conclude the conditional that we want. Oops. And our justification will be 3 through 5 CP. I don't know if the formatting will hold. It's nice if this stuff is off to the side, but it does not have to be pretty at all. The only requirement to get this answer correct is that the last line is the thing you're asked to prove, and that you use rules correctly at every step. Okay, that concludes that proof. Let's do the next one. Again, I recommend doing pen and paper. Complete the following proof. Hint, use IP. Okay, so we're going to use IP. I'm going to start by copying and pasting my premises. I know I'm going to have to use IP, but I see a conjunction, and dang it, whenever I see those, I just take them apart. First step. Might be taking steps I don't even need. It might turn out I don't need both parts. Who knows? I don't know. Formatting is messed up. Who cares? And then I will justify this. I want it to be bigger. So one simp and one simp. Make our text box bigger. Okay, so now what can I do? Can I do anything else? Well, I did get the not X is the negation of a conditional here. I don't know where I'm going at all. I'm just doing things I can do. I could get not G from lines 2 and 4. Modus tollens. Can I do anything else? I could start making some conjunctions, but other than that, no, can't do anything else. And there are no conjunctions I obviously want. So at this point, I'm stuck. And when you get stuck, that's a good time to ask, should I do a subproof? And the hint says use IP. So what should I assume? Well, there's more than one answer usually, more than one thing you could do. But in this, a rule of thumb that works often is a thing you want is the conclusion. And when you do an IP to get a thing you want, you start by assuming the negation of that thing. So if I want this, I should assume the negation of that. So let's start a subproof. And let's assume the negation of this thing. Copy and paste it, which will be just the conditional. Just remember, negating is either adding or removing a tilde. If you instead had left the parentheses and did this, if we had a rule that said whenever you have two tildes, you can just remove those tildes, and such a rule would be a valid inference, but we don't have that rule. We could have that rule, but we could have infinitely many rules, and then it would get confusing. So we picked 5 really common ones. Since we can't just remove 2 tildes because we didn't add that rule, let's just remove a tilde because that's a thing we can do. So let's make our assumption AIP. Let's add a space so it's clear. Our assumption for indirect proof is assume this conditional were true. What would follow? Well, we already got F on its own line, so I immediately say modus ponens. I don't know where I'm going, I'm just going to do it. And that's one of the downsides to indirect proof is you don't exactly know where you're going. You're trying to get a explicit contradiction, but which one and how are you going to get it? Not always super clear. You might form a plan, or you might just start deriving things until you see it. Both are potentially good options, and you can switch back and forth between those plans. Okay, we got this from 3 and 6. Now what do you see? Oh, well, actually, this one's pretty simple. I've got G. I also got not G, so I didn't have to think too hard to get to my explicit contradiction. So 5, 7 conjunction. Great. Now that I have derived an explicit contradiction, I'm done with my subproof. That's the last line is an explicit contradiction. And I conclude the negation of whatever I assumed, since that thing led to a contradiction. So, and that's my conclusion, yay. So let's cite how we got this, lines 6 through 8. Lines 6 through 8 using IP. Okay, question 11. 11 comes with a little video hint. I'm actually going to skip question 11 because I think the video hint is pretty good, but let's maybe say a bit about it. This uses CP and IP. Yeah, I'm not. There's a video hint. When you take the practice quiz yourself, you should watch the video and attempt to do that one. See how you do. Let's skip to the last question. It's really 3 questions, but it's a 3-parter, and it adds up to 5 points. 1 point for this one, 2 points, oh, hey, it's a truth table, and then 3, and 2 points for part 3, a proof. So what we're ultimately going to do is we're going to take an argument, we're going to translate it into symbolic notation. We'll do a truth table to prove that it's valid, and then we'll do a proof to prove that same argument is valid. Okay, so what is the argument? I have either a cat or a dog. If I have a dog, then I have a yard, but I don't have a yard, thus I have a dog. So I'm going to start just by copy and paste the whole thing. Okay, so I need a key. I have either a cat or a dog. I'm going to start by identifying all of the language that goes with our symbols, our operators, either or, that's a disjunction. I have a cat or I have a dog. If I have a dog, then I have a yard, but I don't. Whenever a sentence starts with a conjunction word, that's not necessary. So I don't have a yard, thus conclusion indicator word, I have a cat. So what are my atomic statements? I have a cat. Oh, we forgot negation. Always, when you're identifying operator words, double check for negation. It's the easiest one. So I do have a yard. I do have a cat. I do have a dog. I have either a cat or dog. Okay. So let's let C be I have a cat. And D is I have a dog. And Y is I have a yard. Now we want to put it into symbolic notation in standard form. Okay, so I have either a cat or a dog. I have either a cat or a dog, or I have a dog. If I have a dog, then I have a yard. So 2, if I have a dog, then I have a yard. You could copy and paste the symbols if you like them. It doesn't matter. 3, I don't have a yard, so not Y. 4, therefore, I have a cat. Okay, now since the truth table is here and you've got the proof, this should be pretty easy. You should be able to go check it against the proof. So the point isn't that this is a hard question. The point is to go through the process and see how all these steps are related. Okay, so let's do a truth table. Now we've made a truth table so that each premise has a column in the truth table and the conclusion is also in the truth table. It's one of the atomic statements, so it was already in there. To double check to see that we've set it up correctly, we put the atomic statements in alphabetical order. They're all there. Not Y, its part is Y, that's in the table. C or D has 2 parts, they're both in the table. D then Y only has 2 parts, they're already in the table. So the table's set up correctly. Now let's fill it in. I'm not going to do this part because it'll take a while. However, you should get the answer that this is a valid argument. So what you'll do once you fill in your T's and F's here, according to the rules, is then go over here and just star the only case where all of them are true, and then X where there's at least one that's false, because we're only interested in what happens if all the premises are true. And then we'll go over here and look to see that on whatever rows where all the premises are true, the conclusion is also true. And if that's the case, we'll put an N. Not a problem. If we find a row where all the premises are true and the conclusion is false, that's a counterexample, that's a problem. That would show us the argument's invalid. But if you don't find a counterexample, the argument is valid. And this should be a valid argument because you can only prove valid arguments. And this is a test about proofs. All right, let's complete the proof. Copy, paste. Okay, so what can we do? I'm just going to do the do whatever I see thing. So I immediately I've got a conditional, I've got the negation of the consequence. So I'm going to do modus tollens to get not D. Then what do I do? Well, now I see that I have the negation of one disjunct, so I can get the other disjunct C by using 1 for DS, and that's what I was trying to get. That's the end of this proof. 2-line proof, it's valid. That was way easier than constructing a truth table. Okay, that concludes this practice quiz. I highly recommend completing the practice quiz on your own. I also recommend writing down some of the questions with pen and paper as you're completing the quiz. Doing the practice quiz will help you to get a sense of where you're at on time. If you're struggling with this, the number one thing to do is practice at the level you are at. Go back to the practice exercises. Let's go quick, take a look at those and the video there. Let's make sure we did a good job first. Wow, my computer is being very slow. So if we go to Unit 2, we get everything right. If you think you have spotted an error when you do any of the homeworks or take a practice quiz, do let me know right away, because I wrote all this stuff myself and I am a human who can make errors. It looks like I didn't on this practice quiz, so that's good. Okay. So if you are struggling to do things quickly enough, or you don't fully understand how to construct the proof, the number one thing you should do is go to Unit 2, Module 5 Proofs. My computer, I do not know why it is being so slow, but there are so many practice problems, and they come in lots of degrees of difficulty. And if you are a beginner, you should absolutely do easy problems. And if you are not making progress quickly as you practice, you should reach out for help, and we can have a Zoom conference where we reason through some proofs together. You should watch the video. There's so many resources for doing this. The only way to learn it is to do practice problems until you start to see the patterns themselves. And that's one of the reasons why we're doing this material, is because with this practice, you start to see these patterns. And these patterns can help you to organize what you are seeing when you look at arguments, even when they're not in symbolic notation. At least that's the idea. Kind of, so let's, so here's all of these materials. If you are struggling with a particular rule, go do practice problems that focus on just that rule. Do easier ones before harder ones. There are some crash course videos on each rule that explain the rule. There's also all these longer lecture videos, but they're not that long. And do lots of practice. All of this has, let's see how long it takes to open the thing, but all of this has solutions. So number one tip, do them by yourself before you look at the solutions. Don't look at the solutions to complete the problem. Do it before you look at the solutions. Things look obvious when you have the solutions in front of you. You can't test yourself unless you try it without the solutions. You won't know what you know unless you test yourself, if that makes sense. My point in opening this was just to prove that everything has solutions. But since everything's being slow, I'm going to sign off now and wish you good luck on completing your practice quiz and the actual proofs quiz.